Welcome back once again to another exciting episode of Dave Does Math from Home. Today we're talking about part 2 of section 3.4. Section 3.4 is the product and quotient rule. Hopefully you just finished watching part 1 where we talked about the product rule. Now we're going to talk about part 2, which is the quotient rule, and we're going to talk about this a little differently. When we did talk about the product rule, we sort of went through not exactly a discussion of where it came from, but we talked a little about explaining it and getting it to sort of make sense. I do not have any such discussions prepared for the quotient rule. I'm just sort of going to tell you what the formula is for using the quotient rule. Later, after we have learned the chain rule, Suna says hello. This is Suna. Suna, look at the camera. Suna? Yeah, there she is. She's mouthy. I don't know what she's mad about, but she's mad about it. Later, once we have a very thorough understanding of the chain rule, then I will come back and explain where the quotient rule comes from and why it makes sense and what it's doing. I'm just sort of not prepared to have that discussion right now because it depends a lot on the chain rule. So, you know, what do you want? All of her claws are out. They all need sharpened. Okay, that's enough. Alright, so, quotient rule, bare bones. We're going to do the formula, we're going to use the formula, and we're going to know the quotient rule. Quotient rule formula is this. The derivative of the top over the bottom. So this is the derivative of a quotient, and again, top and bottom are sort of my personal symbols for this. Like when the book does it, I think it uses like f of x and g of x, and I like the words top and bottom. The derivative of the quotient, top over bottom, means the top prime, or we'll say d. Derivative of the top times the bottom minus the derivative of the bottom times the top divided by the bottom squared. There's a lot going on here. There are 5 pieces of this, I guess 6 pieces if you count the exponent. There's about 6 pieces of this, and you have to know how they all mix together. Unlike the product rule, this is subtraction. Subtraction is not commutative. Like, when we're doing the product rule, if you mix up the order of something, it doesn't matter. Because the product rule is all multiplication, and the order doesn't matter. And then it's addition, and the order doesn't matter. So, you can kind of do the product rule however you want. You do not have such freedoms with the quotient rule. This is subtraction. You cannot mix up the order of this one. There's still multiplication here and here. So, you're free to play with the order of those if you like, but I wouldn't. You have to know which derivatives go with which pieces. You have to know the order. You have to know that the bottom is the thing that's getting squared. There are 2 ways to do that. One of them is to do problems like this like 10 or 20 times until you have it memorized. The other is just to write it down somewhere handy and look at it. This is an open note course. Please just write it down and have it in your notebook so you can use that on tests and quizzes. Let's see what it looks like when we do it to this. F prime of x should be the derivative of the top. So the derivative of the top here is going to be 6x squared times the bottom, x squared minus 4, minus the derivative of the bottom. The derivative of the bottom should be 2x times the top. That'll be 2x cubed, all divided by the bottom squared, x squared minus 4 squared. So this is all of the pieces. Derivative of the top, bottom, original bottom, unchanged bottom. Derivative of the bottom, unchanged original top, bottom squared. Here's what we do next. Pay close attention. You put a box on it and you leave it alone. You walk away. Don't mess with this. Don't change it. Don't try to simplify it. Like, I know it can be simplified. We spent years of our mathematical careers just doing distribution so that we know how to do this 6x squared times x squared minus 4. We could FOIL that. I don't want you to do any of that. We're not in algebra anymore. I'm not here to test whether or not you understand the distributive property. I assume that you do. I don't need you to prove it to me. I just need you to show me that you know how to do derivatives and that you recognize the chain rule and can use the chain rule correctly. That is all I need you to show me. And then once you have this written, that's what you have shown me and you're done. Just like in the last section. If you start simplifying this, first of all, if you make a mistake somewhere before this step, and then you start simplifying it, it's going to take me like 5 or 10 minutes of digging through your work to find where you made the mistake. I don't want to have to do that. When you make a mistake, make sure that it's very obvious. Secondly, if you get this right and then you start simplifying it and you make a mistake later, while simplifying it, it's bad. You didn't have to simplify it, but now you've lost points doing something you didn't have to do. So don't do that. Get to here, leave it alone, call it a day. You're done. That's it. Let's do another example. I'm losing some of my quotient rules here. Okay. Let's do something like g of x equals e to the x minus 2x over x to the 7th plus 14. I want a derivative of this, g prime of x, which means I need to use the quotient rule because we have a quotient here. So I'm going to take the derivative of the top, that should be e to the x minus 2, and then multiply that by the bottom, x to the 7th plus 14. I'm going to subtract the derivative of the bottom, which should be 7x to the 6th, multiplied by the original top, which is e to the x minus 2x. And then I'm going to divide all of this by the bottom, x to the 7th plus 14, squared. And then you're done. Put a box on it. Don't mess with it anymore. That's it. That's all I want. Walk away. So that's the quotient rule. Kind of looks like a mess, but if you can remember which pieces go where and how they all combine, doing these individual derivatives is not much of a problem. And then once you have these individual derivatives, you're finished. Don't mess with it anymore. That's it. So, not as bad as it seems. Thanks for coming to my TED Talk.